Hi, this is Miss Park. Today's video is continuing trigonometry, but we're going to move away from sine and cosine of numbers and evaluating and more into algebra and working with sine and cosine of angle theta in general. So this is an introduction to a topic called trigonometric identities. And I'm just going to explain what that means and then we'll jump into the intro. Okay, so an identity is something that is true all the time. So for example, suppose I know from special triangles, for example, that cosine of 45 degrees is the same as sine of 45 degrees because they're both 1 over root 2. So this is true, right? This is true. But an identity means that it's going to be true, the statement is true for any angle that I put in here. So even though this is a true statement about 45 degrees, this is not a true statement for all theta, right? It is not. So an identity is something that's going to be true for all theta. And what we're going to be doing in our next few days in trig is that we're going to be proving trigonometric identities. So for example, we're going to be given some kind of relationship. So let's say, so this is a page out of your booklet. So let's say this one right here. And we're being asked to prove that these two sides are equal. Right? Not given that they're equal. We're not solving for angle x. We are showing that the left side equals the right side. And in order to do that, we need some tools to be able to simplify this right side so that we can say, oh, look, they both simplify to the same thing, so they're equal. All right? So to begin with, we're going to have to review a little bit of algebra. So what would be some useful things from algebra for simplifying expressions? Right? So one thing would be, for example, adding fractions. Right? So if I want to add 1 over sine theta plus 1 over cos theta, so how do we add the fractions? We need a common denominator. So that would be sine theta cos theta. So up here would be cos theta, and here would be the same denominator, and up here would be sine theta. And now I can add these two, and I get cos theta plus sine theta over the common denominator. Okay, and that's a way of simplifying this expression. I added the two fractions, right? Other ways that we could simplify is we know how to expand. So just like we know how to expand, let's say, for example, we know how to expand x times 1 minus x, right? We can distribute the x and you get x minus x squared. We can also expand sine theta times 1 minus sine theta. Right? We can do the same thing, but with sine and cos. So distribute the sine, so I get sine theta minus sine theta times sine theta, which we write as sine squared theta. So we read it like this, sine squared theta. All right, very important that the squared is squaring the sine, not squaring the theta. It's not the same as sine theta squared. We don't want this because this is saying square the angle. So if the angle was 30 degrees, this is saying take the sine of 30 degrees and square that number. This is saying take the sine of 900 degrees. Right? So we're not squaring the angle, we're squaring the sine. So this is what we want to see. Right? So that's how you simplify expressions. What else can we do? Oh, we can actually factor expressions. All right, so this will be a simplify. This would be a factor. So let's say, for example, I want to factor cos squared theta minus sine squared theta. So you might look at that and say, factoring means write it as something times something. Recognize what is this, right? And hopefully you'll recognize that that's a difference of squares. And if this confuses you, the cosine and the sine, it's the same as if x was cos theta, if you're going to use x and y to represent cos theta and sine theta, so that's the same as x squared minus y squared. And you know how to factor that. So you can do it here. So it's the difference of squares, so x plus y times x minus y, and then put these back in. Or if you are comfortable with the way this looks, you can factor directly. So this is cos theta in both brackets, sine theta in both brackets, a plus and a minus, and it's factored. Okay, so the same techniques, the same algebra techniques that we've always used, we will use again. So lots of different ways. So here, I'll grab one from your homework for factoring. So this is question 2I on page 206. And it says to factor cos squared theta minus 5 sine theta cos theta minus 14 sine squared theta. So to factor. Right? And they look really scary because of the sine and cos, and it looks like a big long sentence. But if you realize that all we have here, we have something squared, here it is again, and we have this thing here, and here it is squared. We can do our change of variable, which we've done many times in our course. So we let x equals cos theta and y equals sine theta, and now I have x squared minus 5xy minus 14y squared. And hopefully you're still okay with factoring this. This is just a simple trinomial, right, where the terms begin with x, and then the second term will have a y in it. Two numbers that multiply to negative 14 and add to negative 5, so that would be negative 7 and plus 2. But once you've got it factored, now you just need to put your sine and cosine back in. So cos theta minus 7 sine theta times cos theta plus 2 sine theta. Okay, so hopefully you're seeing it's exactly the same as all the algebra we've ever done. Okay, now there is one new thing. So I'm going to show you something a little bit different. Remember, the idea here is to prove identities. So to prove that two things are equal, and I showed you the example of what we're going to prove that they're equal. We're going to need some tools in order to be able to simplify things more than just the algebra that we have. And here are two tools. So this is also in your booklet. Here are two identities that we're going to prove now, and we're going to use them in every question afterwards. So once we have proven these two, we can use these as tools for all of the other proofs that we're going to be writing. So the first one is called the quotient identity. And remember, identity means a relationship that is true for all theta. Any theta that I put into here, as long as they're all the same, this will be true. So if you take theta is 61 degrees, put in your calculator tan theta, and then put in the calculator sine theta divided by cos theta, you'll get the same thing. But we want to show that this is true for all of them, okay, for all thetas. So how do we prove this? So I'll give you a moment to think about how to prove it. If you like, stop the video here. You don't need anything more than what you already know. Here, I'll even draw you a little diagram with your theta and see if you can prove it. All right, so stop the video here and then start it up again when you're ready. Okay, so I'm going to show you the proof for that identity. And it goes like this. Okay, so this one was already done. So it goes like this. If we draw our triangle, we have hypotenuse, opposite, and adjacent, and labeled. And when we work on proofs, this statement is what we are trying to prove. So we can never begin with this statement at the beginning because we don't know that it's true. So you might remember that concept from when we're doing equivalent rational expressions. Show that one expression is equivalent to another. We could never start with them being equivalent. We had to simplify one of them, simplify the other one, and then if they simplify to the same thing, we could say, okay, they're equivalent. So I'm going to work on the left side, which just says tan theta. And tan theta is opposite over adjacent there. And the right side is sine theta over cos theta. And I can put in those definitions right into the fraction. But then when I go to divide the fractions, I multiply by the reciprocal, and the hypotenuses reduce away. And I'm left with whatever's in the right side equals whatever's in the right side. So then I'm going to write my concluding statement, which there's no space here, so I'm writing it here. My concluding statement is, so therefore, so left side equals right side, and that's what I was hoping for. So what's the conclusion? Therefore, tan theta equals sine over cos. So we restate the thing that we're trying to prove. So I work on one side, work on the other one. Oh, they're equal, that's wonderful. Say that they're equal, and what does that mean? Well, that means that this is an identity, that this is true. All right, the next one on the page is the Pythagorean identity. So this one's called quotient because it means division, dividing sine by cos. This one's called the Pythagorean identity. It looks similar. It's got the squares and you're adding them up. Looks similar to the Pythagorean theorem. So let me give you a moment and try to prove this one. You can use the same triangle that we used for the first one. I can pause the video here, and then I will show you the proof. Oops, I'm sorry. Okay, so here we are. I'm going to show you the proof to the Pythagorean identity. So here I'm writing my left side and my right side separately. I cannot write them with an equal sign because we don't know that it's true. And then I'm going to fill in what I have from this triangle that I drew for the first one. All right. So I have opposite squared over hypotenuse squared plus adjacent squared over hypotenuse squared, and I can add them up because they're over a common denominator. And now my right side is 1, and my left side looks like this. And now the question is, how do I get this to equal 1? So if you're able to get to this step, this is great. But now how do we get this to equal 1? So hopefully you've had a chance to think about it. But if you look at the triangle, this is a right angle triangle. So we can simplify opposite squared plus adjacent squared, right? This is a right angle triangle. So that's using the Pythagorean theorem, you'll get that that is equal to the hypotenuse squared. So my fraction becomes this because of the Pythagorean theorem, and that simplifies to 1. And so now I can conclude, oh, the left side equals the right side, therefore this thing is true. Okay, and those are our first 2 trig identities that we have proved. Now we proved these using adjacent, opposite, and hypotenuse, but we never have to do that anymore, because once we have proven these 2, and we've just done it in this lesson, from now on we can use these 2 for any other proof that we want to write. So for example, if I take a sample page, so let's say I take this one over here, I'll prove the identity. Okay, so let's say I take this one. So I'll just do the example. So remember, I'll write it on top. The only tools that we have is the reciprocal, is the quotient identity, which is this one, and the Pythagorean identity, which is this one. And we have all our knowledge of algebra. So that's adding fractions, factoring, expanding, all that stuff. These are our tools. And that's all we have. Okay, nothing else. So we don't need adjacent and all of that anymore. We have these ones we can use whichever way we need to. So let's look at B. And so we're going to try to do quick proof. So the left side is cos x, and the right side is 1 over cos x minus sine x tan x. Notice how my first line is always rewriting the question, but on separate sides. Left side, right side. Okay, that's how we start. And now I'm going to look to see. I don't think I can do anything with this 1 over cos x, but if I can apply any of these here, so I can apply the first one, I can get rid of tan x, so I can apply the quotient identity. Oops, not equals, but minus. So I have minus sine x times sine x over cos x. All right, and now it's algebra, so I'm going to put these 2 fractions together. So this is sine squared x over cos x, And this one's going to be the common denominator now, so I can put the numerator together, the two numerators, and I get this. But keep your eye on what you need it to equal to. We need it to equal to cos x. This one's got signs in it. This one doesn't. This one has just a cos x. So let's look again at this fraction and see what needs to be done to get rid of the sign and just the cos x. Remember, the only tools we have are here. Right? So I could factor this into 1 plus sine x times 1 minus sine x, and that's fine. It would be equal, but that doesn't look like my left side, so it's not helpful. So the only tools I have are here. So to be creative, I could say, you know, sine squared x is in this identity. There is a sine squared in this identity. And if I rearrange this identity, then I could get a different form of the top. So 1 minus sine squared x is what you get when you move sine squared x to the right. And what you end up with is cos squared x. So rearranging this formula gives me that cos squared x equals 1 minus sine squared x. So this is going to be cos squared x over cos x. So notice, it's the same tool. I just had to rearrange it. So all you're allowed to use are in here, but you might have to do some rearranging, okay, for whatever you need. And that reduces to cos x. And look, I have my left side equals the right side. Therefore, I'm going to restate the identity. Cos x equals 1 over cos x minus sine x tan x. Okay, and so really this line should be after all the other stuff, but there's no space on the other side. Okay, and that's how you prove trig identities. And if you look in this booklet, you're going to have page after page after page of identities. Look, oh, look at this, right? And so you're going to end up doing dozens, maybe 100, right, of trig identities to get really strong and really fast. The more you do, the stronger you're going to get. And it looks like a big mess right now, but you're going to have to start from the beginning, start with the easy ones, and then get harder and harder. And these ones, remember, all of them, the only tools you have are these two identities and your algebra skills. That's it. That's all you need. And so all of these can be proven using just these tools. Okay, there is one other tool that we may need for some of them. It is still an algebraic tool, and we've used it before, but stay tuned. We'll cover that in class, and otherwise you get stuck on some of them. But most of them you can do with just these three. All right, so good luck. The key here is practice, practice, practice. The more you do, the better you'll get. Thank you, and thanks for watching.